What's up, intermediate algebra? Mr. Smith here for your weekly video. Just remember, your only goal for this video is to watch, listen closely, and write down 2 things that you learned, and then one question that you still have, and you'll submit that online. This video is going to launch us into what we're doing tomorrow. So again, this one's going to be a short one. It's going to be about 12 minutes long. Buckle your seatbelt. The topic is solving inequalities. Okay, today on the Desmos activity, you learned kind of how the inequalities are a little bit different than equations, right? For an equation, like x equals a number, that's one solution. Maybe it equals a couple different things. But with inequalities, you have an interval of solutions. So if x is greater than 6, then any number that is above 6 works. So literally 7, 8, 9, 10, 11, 12, all the way to infinity. So this is one way we can algebraically represent that. Algebraically is with x is greater than 6. We could also do it numerically with a number line. Check this out. Imagine if we have a number line and we want to represent every number greater than 6. Well, we would put 6 right in the middle, and we would shade every number greater than 6. Okay? And then the last piece to that, to a number line, is we would use an open circle if we do not include 6. Notice, this says, this is key point, by the way. This says that x is greater than 6. So 6 would not count. If we said x is greater than or equal to 6, then we would need to use a different way to represent that. If we said or equal to, we would need to fill in that dot to show that 6 actually counts as a solution. That's a big thing, depending on if you're going to get the answer right or wrong. So x is greater than or equal to 6. That's how we show it graphically. We could also just say this: x is greater than or equal to 6. Right? That would be using words. So that would be using words. What else? Oh, last one. Numerically. There's a way using what's called scientific notation, not scientific notation, interval notation, that we can represent that. X is greater than or equal to 6. So I could say this. I can say it starts at 6 and it goes to infinity. Okay? This is the numerical representation. That's called interval notation. But check this out. That says 6 to infinity. But I forgot to include 6. If I need to include 6, I don't use a parenthesis. I actually use a bracket to show that 6 is actually a part of your answer. So look at those 4 things. And I challenge you to do all 4 of those again with this. A is less than -2. I challenge you to represent that graphically first. I challenge you to write that in words. And I challenge you to write that numerically in interval notation. Pause the video, and then when you have it, unpause and see if you match what I got. All right. Hopefully you paused. I'm assuming half of you did, half of you did not, and you're getting the answer key, you cheaters. Here's what we got. A is less than -2. So if I'm going to draw a number line, put -2 in the middle. A is less than, so it's going this way. And it's less than, it doesn't include -2. It doesn't have that little line under it, so I'm going to put an open circle. So there is my graphical representation. My verbal, I'm just going to type this. X is, wait, it's not X, it's A. A is less than -2. So that's an easy one. And then numerically, this is the hardest. How would we show that it can be any number less than -2. We actually need to do this. Since we're going left, the lowest number is going to be on the left side of the parentheses. So this is going to be -2. And how do I show? See how I used a positive infinity here to show that the lowest number is 6? Lowest number is 6. And then the highest number is infinity. Well, how can I do the other way? -2 is the highest number that it can be. Our answers are less than. So we're actually going to go to negative. That's a horrible infinity symbol. We're actually going to go to negative infinity. That's beautiful. Okay, that's the numerical. So these are some inequality basics. Now what we're going to do to finish the video, second half of the video, is we're going to solve one. And I'm going to show you two things. One, when do we need to flip our inequality sign? And number two, when do we have no solution or infinite number of solutions? Okay, when are those two sections? That's what we're going to talk about. So first, and most important, when do we flip the sign when solving? I'm just going to make up a problem. I love being able to do that. Switch into blue. Let's just make it up, which means it's probably not going to work out great. Let's go -6 plus 2 times n minus 5 is greater than or equal to 12. Let's see how that works. Okay, just like an equation, we draw our line down and we're starting to get our variable. We're looking to get our variables by itself. We're trying to move everything away. My variable is right here, so I need to move everything but that n. So I can add 6 over to the right. So I'm going to go ahead and do that. Well, I've been telling you to distribute first, so let's just distribute first. -6 plus 2n, 2 times -5 minus 10 is greater than or equal to 12. Now I can move the 6. Oh wait, there's a -6 and there's a -10. Let's combine those like terms. Remember, that way we don't have to move them both separate. Honestly, I could just add 6 and then add 10. But why wouldn't I just combine them first to a -16 and then I can move it just one time? So see, I'm just working my way down this equation. I need to get n by itself, so I'm going to add 16. And I'm now at 2n is greater than or equal to 28. Okay, moment of truth here. Wow, this is going to work out to be a whole number. Nice, I'm a genius. We divide both sides by 2. Cancels. And n is greater than or equal to 14. That is our answer. That is our answer. So notice how the inequality sign never flipped. It stayed the same the whole way. Let me show you how when it would flip. And to do that, I'm literally going to have the exact same problem, but I'm going to change this to a minus sign. Okay, and I'm going to take this away just for the sake of the problem. Check this out. -2n plus 10 is greater than or equal to 12. We subtract 10 to both sides, and we have -2n is greater than or equal to 2. Now, if you ever divide both sides of an inequality by a negative number, so right here, I'm dividing this by -2 to cancel, I'm dividing this by -2. If you ever divide by a negative, you have to also flip the direction of your inequality symbol. Notice what happened. It's pointing this way towards the variables. The second that we divide or multiply by a negative number, you must flip sign. When you divide or multiply by a negative number, you have to flip the sign, okay? If we had x over negative 2 is less than 4. If we divide, or if we multiply by negative 2 over here to get that to cancel, which means we have to multiply by negative 2 over here, then we have to flip our sign before we get the right answer. Okay, that's the first thing. Second thing, and then how would we graph that, obviously, real quick. We already did this, but you're going to want to graph on the homework. You stick the negative 8 in the middle, and it says x is greater than. So you open circle, and you go greater, and you shade that area. Okay? Interval notation, you would say goes from negative 8 to infinity. Basically, when I see that, because I'm familiar with this, I just see every number above negative 8. You always put the lowest number first and then the highest number next. All right. Lastly, it's the 11-minute mark. I'm stopping at 13, so 2 minutes. What if we get a no solution? What if it's this problem? Negative 8n plus 6 is greater than negative 2n plus 2 minus 6n. Watch this. Combining my like terms, I see this and this over here makes negative 8 plus 2. I need to get my numbers together, so I'm going to subtract 6 over here and 6 over here. So I'm going to have negative 8n is greater than or equal to negative 8n. What's 2 minus 6? Negative 4. Check this out. I'm almost done, but look what's going to happen. I need to get my n's together on the left. So I'm going to add 8n, cancels here, it cancels there as well. So we literally have 0 greater than or equal to negative 4. Is that possible? Can you have, is 0 greater than negative 4 or equal to? That is a true statement. 0 is greater than or equal to, is 0 or equal to negative 4? Is 0 equal to negative 4? Heck no, it's not. So this is no solution. In no world is 0 equal to negative 4. So if your variables ever cancel out and the statement that's left over is false, then it is no solution. But what if your statement left over, what if it had been negative 4? Or what if it had been, 2 is greater than negative 4? What if that had been what was left over? You have to ask yourself, is 2 greater than negative 4? It sure is. It sure is. So every number that we type in is going to end up getting this and working. So there are an infinite number of solutions. Okay, so in conclusion, if something ever happens to where your variables cancel out and you're just left with a statement like this, let's say you're doing a problem on your homework and you get all the way down to the bottom and all that's left is 2 greater than 1. If that's a true statement, then you have infinite number of solutions. If it was the other way and it was, say, 2 is less than 1, that's false. So that's no solution. All right? So remember, 2 things you learned and 1 question that you have moving forward, and we are going to get after this tomorrow in class. Love you guys. See you soon.